Hi everyone, welcome to my session. I am super excited to be the speaker at Conf42 Prompt Engineering Conference. In this talk, you will learn what are the generative feedback loops and how to use them to create the personalized recommendation solutions and generate the targeted ads based on the real-time information. This session can be specifically useful for Python developers, data engineers, or Supabase or VB8 users looking for solutions for detecting changes on primary database like a Supabase or PostgreSQL and streaming these changes and continuously updating vector databases for AI-powered applications. Let me introduce myself. My name is Bobur. I'm a developer advocate at Glassflow. I'm also Microsoft's MVP for Azure AI services. If you have any questions, please scan the QR code and connect me on LinkedIn. I will be more than happy to address all of your questions. Here's what we will be covering today. We'll start with an introduction, what is a generative feedback loop, and followed by the real-world use cases and real-time GFL pipeline architecture. I'm going to explain and show you the components, how to detect changes on your primary database, and streaming these changes, continuously updating your as a destination vector database when you are building AI-powered applications. And you will see also demo of building a typical pipeline with technologies like Glassflow, Supabase, and VB8 for our simple listing application to optimize and personalize these property listings for Airbnb. This will be a live demo of running the production-ready pipeline in 15 minutes. By the end of my session, you will be able to process simple Airbnb listing data, which is in Supabase, and enrich it with AI and store it vector database like VB8. And you can also search through these enriched listings in the VB8 using VB8's Graph Console. I am incredibly happy to have such a knowledgeable audience in this session and this webinar. So let me start by understanding what's the feedback loop. Feedback loop actually relates to the use of current outputs to optimize the future results. It involves, as you can see in the diagram, utilizing outputs to generate better inputs in the next stage. And feedback loops are critical components also in training AI models. Like when you give some AI model data, a model you can train, but in real time also user input can impact on the model responses in real time. Generative feedback loops, or shortly GFL, takes also approach of generative AI, but it takes a step further by introducing continuous improvement cycle. As you can see in the diagram, in GFL, the output generated by the AI, when you do prompt engineering, is not just a final product, it's a part of ongoing process. Usually GFL takes the results generated from the Gen AI or from your language models like GPT, vectorizes them and saves the result back to the vector database, and you can use this generated data for future AI processing. And this output is used to also improve the future results from the AI models. In other words, the outputs become the inputs for the loop cycle. And AI outputs are analyzed to optimize training data for the AI or algorithms, parameters. The goal is to improve the quality of the future content generation. Let's think about AI can generate the code snippets based on the user's requirements and create a feedback loop which tests to improve the code over time. Some people always confuses GFL with Gen AI. Gen AI, we know that it primarily operates in a one-way direction. It generates the content based on the input data you provide for AI. However, GFL, on the other side, incorporates a feedback loop, where AI solution continues to learn and improves from the outputs as it's generated. And Gen AI, we know that typically use it for creating new content or new data, summarizing existing data. But GFL is focused on improving AI outputs over time solve the cycle of feedback loop learning. And GFL solutions are more complex than the standard Gen AI models because they require mechanism for collecting feedback from the users or from the human, analyzing it and adjusting the AI models accordingly. Let me bring a couple of examples. A good example of GFL in action can be the personalized recommendations, where AI might suggest products to user based on the, let's say, browsing history or clicks or purchases on online store like a website. The users further can interact with these recommendations to provide the feedback to AI to refine the future suggestions. In the real estate, another example, in the real estate industry, for example, property listings are often updated if you want to buy or rent an apartment with new information such as the price always changes, availability also changes, and additional features like you can add software, you can remove the refrigerator and so on. And GFL pipeline can automatically update these descriptions of, let's say, real estate listings or information by making sure that they are always currently optimized for search engines. If you open a Google and then search for a specific apartment, if the apartment data changes in real time, you can see also this reflected on your search. Other examples, you can apply the GFL to the other industries like real-time job listing optimization. For example, the platforms like LinkedIn can use this GFL if the AI detects, let's say, someone searching for remote work or flexible hours. It can update the relevant job listings to emphasize these expectations or aspects, thereby increasing the visibility of your job posting to the candidate to make it more attractive for them. Or you can use the same solution, GFL, to customize travel itineraries. This is one example I like. Let's say if you frequently search for some new trips online or cultural experience in different countries, and AI can generate some itineraries to include some activities that perfectly aligns with the preference of the user. And other examples like TV shows, you can, like Netflix, can use to create a personalized viewing experience. In Netflix, you can always see the quite relevant movies based on your historical watch it, like the movies. Always it will find something relevant to your emotional experience. If you want to learn more about the GFL, I found this article by the author Connor. He explains very nicely concept of generative feedback loops with large language models like LLMs, how you can retrieve the information from a vector database such as WeWait to prompt vector databases, generative model, and then vectorize and save the results of the AI generated content back to the database. And let's focus on now GFL with real-time data. As you can see in the diagram, real-time data transformation and this transformation are the backbone of a very effective GFL automation. It's about detecting real-time data changes and continuously updating vector storage on the right side. In the context of Airbnb listings, this means as soon as new room is listed, the description for the room can be created by the AI and vectorizes for better search. And then you can store the vectorized result in the vector database. Let's say user searching for a cozy apartment in Paris using Airbnb, and he can see all up-to-date options for him in the same location. And the real-time transformation also here, what it does, as you can see, if you see the yellow square is a sort of pipeline. We are detecting some changes from APIs, files, databases where exactly Airbnb listings located. And then say if new Airbnb listing is added, we are generating a description based on the Airbnb listing attributes. We are calling OpenAI or other models, chat compilations and foreign. And for the generated content from the AI, we are calculating vector embeddings. And then we are sending vector embedding to store somewhere in the vector database. Why we are storing in a vector database because we would like to build in the next step like simple the application to give the booking.com's experience to the users. They can search for some apartments by using their human language. And then this human language can be also converted to the vector embeddings, and we can compare our data corpus we created in the vector database to find the matching the apartments for the user query. This is everything is happening in real time. As you can see in the previous slide, I showed you data can change here maybe every minute or every 5 minutes, and this data is captured, and in milliseconds the data will be visible in the vector databases. This is the concept of real-time GFL, how that works. And now let's focus on some of the technologies to build, how we can build these pipelines. One of those technologies I'm working with also helps you to build real-time data pipelines for AI use cases. Like you can build a pipeline such as real-time GFL using Glassflow. And Glassflow simplifies also creation process of your real-time data processing pipeline. As we have seen previously, you may spend up to 15 minutes to setting up everything, and your new pipeline is ready to run in a production environment. And also with Glassflow, you can integrate with various data sources such as PostgreSQL, MongoDB, or some message brokers like Google pops up, message queues like Amazon SQS, and you can apply transformation in the middle. Then you can store the results to the databases or BI analytics tools or vector storages like ViewWait. So this is how it works. The Glassflow, why we decided to build this solution, especially for Python developers. We are trying to offer all-in-one platform for that focus on the easy creation of your data pipelines for data engineers and data teams, especially for data scientists. You don't have to worry about the infrastructure under the hood. In other words, it removes the complexity of the real-time for data processing pipelines, with Kafka plus Flink. You can do everything in a single cellular infrastructure. Let me explain how that works, building a pipeline with Glassflow. Let's say you start with connecting to your live data sources like Airbnb listings using built-in integrations, or you can build your own integration using Python SDK. Then you start to build your pipeline within a low-code environment like Glassflow Web App, or using the CLI if you prefer like CLI option. Then you implement your transformation function, which is a very heart of the transformation in Python. And you can, after your transformation function is ready, you can deploy to serverless execution engine, where your transformation can scale up to processing like billions of records. And you don't have to worry about scaling manually. And then when a transformation is ready, and you can send the output events to the internal destinations using the same integrations or building integrations. This is some of the use cases you can achieve with Glassflow. You can build your pipeline, for example, to enrich your data with predicted future prices using AI, and to detect some changes in your database, and also sending these data changes by transforming to the destinations. You can also build some, let's say, real-time clickstream analytics dashboard to analyze click streams data from your website and send them to other downstream applications. If you want to know more about Glassflow and Glassflow use cases, you can scan this QR code. It will bring you to the GitHub repository, where you can try some of our real-world examples and run them just right from Jupyter Notebook. Now let's come back, switch to our real-time generative feedback loop automation. We're going to build, as a part of the session, simple pipeline for GFL to make a feedback loop pipelines. As you can see here in the diagram, we have data source. Let's assume that Airbnb data always stored to the Supabase, because while using Supabase is open source first of all. Then It is another alternative to Google Firebase, which works quite nice, especially when you have a real-time data and your data always changing in your database. Let's say whenever a new Airbnb listings added or you updated existing one, and Superbase can trigger an event to send this change directly to the Glassflow pipeline. Using it is a webhook data source connector. Every change happening in Airbnb listings can be actually sent to automatically to the Glassflow pipeline, and when it reaches the Glassflow pipeline, you can do AI and vectorization. You can write transformation function to apply some AI-driven solution, AI-driven insight in Python. In this case, let's say AI model can call the OpenAI to enrich listing and descriptions by generating more description for the Airbnb listing. You can summarize it and then transform it, all the descriptions, and then at the same stage will be vectorized and converted to the vector format, and it will be sent to the vector database like a wheel weight, as you can see in the diagram. I will show you why this approach and why we are calculating vector embeddings, and again, like we're storing a vector database. You will see in the next slides, I will give you some of the example queries. It will give the more clear querying option for users. They don't have to use SQL. If data wants in the vector database, they can acquire the data using their human language. Let me explain what is our sample data set to train our AI or to build the pipeline. And we can use like a sample CSV data set, where there are some room listings, let's say in New York City from Airbnb last year in 2023. And this data set includes every Airbnb listing attributes such as a listing name, host name, location details, room type, price, availability, and so on. Once a data set we have here, what we can do by running this pipeline and saving to the data to the wheel weight, we can run typical queries, like we can fetch, let's say, top 5 most reviewed listings in New York or in Brooklyn. This could be quite useful to identify popular listings in this area. Or you can find the listings in Brooklyn that are budget friendly, let's say less than $100 and have a positive reviews, something like that. Or you can also search for the queries. A user might be looking for listings that are described like I want to have a apartment with a great view. This query would return the most relevant results based on the user queries. And this conversion from the human language to the vector query operation will be handled automatically by the vector database like wheel weight. Once you understand the pipeline in GFL, let's build this pipeline step by step. Here, how we build our pipeline. Like we start with setting up our vector storage, which is our final destination. We create a pipeline with the Glassflow, and we set up the Superbase with a sample Airbnb data. Then we run the pipeline. Once data already in a wheel GraphQL, I will show you how you can query wheel weight using this GraphQL console. Let me bring your attention to the demo. Here, as you can see, the demo in place. I will start by creating first, setting up the wheel weight cloud. You can create the first cluster on wheel weight. Then once the cluster is up and running, you can start to create a new collection inside your cluster. It is called, let's call it Airbnb NYC, which is Airbnb data in New York. Then you choose a vectorizer type, like in my case, I'm using text to vector from the OpenAI. And if you choose a model like text embedding, 3 small or large, for me, it's 3 small is enough. And you can keep the rest of the configuration by default. So as a next step, and now once I have the viewer site is ready, I'm going to create the pipeline with Glassflow. You can sign up for it for free. You can get a free account, and then you can create your first pipeline easily. Let's create a new pipeline. And then choose a data source as a webhook, because we are getting data from Superbase as the events, change events through the webhook. The third step is defining your transformation function. You can define by writing the Python code. As you can see, I have created already one sample transformation function. It simply receives from Superbase Airbnb listing data, and using the OpenAI, it generates the description from the Airbnb attributes. Then after AI responds with the generated Airbnb listing description, we're gonna create the vector embeddings. As you can see, it has a handler function, which is important function for Glassflow. It automatically detects whatever inside the your logic under the handler function. And then our transformation function is more or less ready. So next step, yes, also don't forget to include your dependencies like OpenAI dependency for my transformation function or PyFile. And next step, I'm gonna define data sync operation where my transformed data will be sent. Again, I'm gonna choose webhook because output data I will send to view weight collection that we created with you in the before. So I'm gonna find first the view weight cloud API key and the URL. I need a URL for my cluster. I just copy paste the URL for the cluster, and then I will bring the admin key for that. Let me find the admin key from view weight console, and then we need to define also content type, like application JSON. Then it's mandatory to define also the API key to make sure that we are securely connected to view weight cluster. Then we send our data from the Glassflow pipeline. Here we go. I have the bureau token and authentication is done. I will click on the next step, and you can see the overview of your pipeline. And when you press the click pipeline, your pipeline is ready to run in serverless environment. And the last step is setting up the Superbase. Make sure that you have a Superbase account. Assume that I have my already created simple database called Airbnb NYC. In Superbase, you can see I had two different data sets. This one is from 2019, and it has some attributes to map the Airbnb listings like hostname, location, room type, price. Then once I have this data in place, I can go and navigate to the table editor to see sample data. As you can see, I have now existing sample data, 5 listings in place to give you understanding like this is how the data looks like. And I will create a webhook trigger on Superbase because Superbase triggers using the webhook of the Glassflow pipeline, right? Let's create our webhook. I can call it, give it any name. In my case, maybe Airbnb listing or Airbnb data change capture because it detects the changes and sends to the Glassflow pipeline. And you really gonna next step choose a database table, which database table we are choosing, and events like insert, webhook when it should trigger in insert or and so on. This and also next step is we need to also define Glassflow pipeline access token in the webhook URL because when the Superbase calls the Glassflow, we need to securely make the connection using the access token. I put it in the header of the Superbase webhook access token for the Glassflow. Now, as you can see, the pipeline for the webhook is ready. And make sure that you need to enable real time for your database because it should get real time updates. Now everything's set it up. Next step, I'm gonna send some more sample data to Superbase because you remember we had only like 5 listings. Let's add maybe 10 or 20 more. For my listing, as you can see, I have a bunch of them in the sample data set. And I have also a Python script to populate the Superbase with sample data. It just inserts rows of data in batch mode. We are just simulating some incoming or registering new listings. But in reality, any service can call these to insert some more data. And let's run this Python script and generate some input data. I'm going to create 20 more rows for the super-base listings. Here we go. I added 20 more. Everything's successful. And now I can switch back to the super-base and check if this data already in place. Yes, as you can see, the data is in place. And now we can go to Glassflow and check if the data received by the Glassflow after we did insert on super-base side, right? At real time, what's happening. Yes, here we go. As we inserted, every insert detected by super-base and sent to the Glassflow pipeline, which is where the magic is happening. And Glassflow is already in milliseconds processed these events and sent to the super-base after this transformation. And I can now ready to query and search for irrelevant listings and review the GraphQL console. I did one query like to find 5 most relevant listings in Brooklyn. Yes, here we go. Here some listings. And now let's try some query using the human language. For that, you need also the OpenAI key, because it's going to use AI to like human interactive searching. I'm going to pass my OpenAI API key. Let's say when user might be asking like luxury apartment with a nice view. And as you can see, it found based on the human language relevant data in our database. And the summary is actually generated from the AI generated summary, but we had in the beginning only the data about the Airbnb listings. And this generated data summary can be always changed and enriched based on the property, something updates on the property side. If I change now and find any property and change the price for the property, it will be reflected immediately on the view weight. This is how the real-time continuous vector embeddings generation and vector database dating works. So that was my demo. In summary, we have so far presented the concept of the generative feedback loops, and this describes, let's say, not only using the results from the database to answer the user's queries, but we can also save the result once we save the results back to the vector database again for future references. So this is we call it GFL, and real-time GFLs uses real-time data to receive like a user input and change the AI output based on the user's interactivity. So you can always get the most relevant and updated content using real-time GFLs. So I hope you find the session interesting. If you have any questions, now we can jump on a Q&A session or leave your questions in a comment and scan this QR code to find the use case I showed you with GFL, also other use cases. Do you want to try out? You can try out some of other use cases. Thanks for your attention and have a nice day.